Hi everybody, so now we're going to continue our note on graphing trigonometric functions. So now we're going to talk about transformations, and I've already filled this out for you because, surprise, surprise, it's the same as it always is with transformations. Our A, K, D, and C values have the same meaning that they always have had, so you can get this down. Vertical stretch where the absolute value of A is greater than 1, or a compression where the absolute value of A is between 0 and 1, reflection on the x-axis. K is a horizontal stretch if the absolute value of K is between 0 and 1, or a compression if the absolute value of K is greater than 1, and if it's negative, that's a reflection on the y-axis. C is a shift up and down, and D is a shift left or right. So what's more important with trig functions is what each of these parameters tell us. So remember that the amplitude normally on a sine or a cos curve is 1. So when it's multiplied by a factor of A is the new amplitude. So it's always the absolute value of A is the amplitude. So it's always of the form y equals whatever the absolute value of A is. That is the amplitude of the function. 2 pi divided by k gives us the period of the function. So for example, if you have y equals 2 times sine 3 theta, then that means that it's been compressed by a third. So it makes sense that the period, which is normally 2 pi, is just 2 pi, a third of 2 pi, or 2 pi divided by 3, which is the k value. Okay, so people sometimes get confused because when they identify that it's a compression by a third, then they want to divide by a third instead. Just think about what it is you're doing. Okay, you want to divide by the k value. So in this case, the k value is 3. And think about it. If it's compressed by a third, then that means you would be multiplying it 2 pi by a third. So make sure you're really making sense of what you're doing there. Okay, y equals c is the equation of the axis because our normal, oh sorry guys, it shouldn't be, when I said y equals a before, I was thinking about c, so erase that, that's not included. When it says the equation of the axis is normally 0, so however much this function has been lifted up or down, that's the new axis. And D will now be given in radians. So the shift left or right will be in radians, not degrees. Okay, so that's important. Some tips for graphing. Begin with the key points of one cycle. So the zeros and the max min points, and then just transform those points. So if you're starting with sine, just start with your 0 up, 0 down, 0. Okay, if you're starting with cos, you go max, 0, min, 0, max. So you always start with those 5 points and just transform those 5 points and your life will be a lot easier. Okay, with tan, you start with 0 up and then up with a 0 there, etc. But you know what? Tan honestly isn't going to come up that much. Remember to factor out the argument to find D, so you have to factor out K as per always. So remember, if you have y equals 2 sine bracket 3 theta minus 9, okay, your D value is not 9. You have to factor out this 3. And now you can see that your D value is actually 3. So be careful about that. Okay, and then you want to investigate the axis, the amplitude, the period, and then apply the horizontal translation last. Okay, so you can usually do all of these things in one step. That's step 1, and then apply this after. Okay, so let's see this in action here. So find the equation and sketch y equals sine x just for one cycle. So between 0 and 2 pi that underwent the following transformations. So it's had a vertical stretch by a factor of 3. So that means our A value is 3. Okay, that also means the amplitude is 3. It's had a horizontal compression by 1/2. So that means our K value is 2. And that means that our period okay, is 2 pi divided by 2, which is just pi. So in 2 pi, we're going to have 2 cycles. Okay, our horizontal translation is pi over 6 to the left. So therefore, our d value is negative pi over 6. And our vertical translation is 1 down, so c is equal to negative 1. That also means that our axis is y equals negative 1. Okay, so then our equation can be written like this. Y equals, so A, 3, sine, bracket, K, 2, and then we have to show our D factored out, so theta plus pi over 6, remember, because it's negative and negative, so that becomes a plus, and then we subtract 1. So this is the function that we are going to graph. So get out a piece of graph paper, and we're graphing it using this information. So I'm going to hop over to my graph paper here. Okay, so I like to do it in terms of 4 because I know that my period is pi. So 1, 2, 3, 4, that'll be pi. And 1, 2, 3, 4, that'll be 2 pi. So then this here will be pi over 2. And this here will be 3 pi over 2. Okay, so this is theta. Okay, then the first thing I like to do, pay close attention guys, is I like to graph my axis. Okay, so I graph my axis there at y equals negative 1. Okay, so y equals negative 1, that's my axis. And this is a sine curve, so I'm going to be starting on the axis at 0. Okay, I'm also going to be ending after 1 period. So my period is pi, so I'm going to be ending at a 0. And also halfway between, I'm going to be on the axis as well. So sorry, they're not zeros anymore, they're on the axis. Now, I haven't done any reflection, so halfway between my first 2 axis points is going to be my maximum. I'm going to go up and then down. So my amplitude is 3, so my maximum is 3 units above the axis, so it's at 2. And then halfway in between my next 2 sets on the axis, I'm at my minimum, so I go down 3, because again, my amplitude is 3. So there is the first version of my curve, and now I can continue that again for another repetition. So I end on the axis, halfway through I'm on the axis. In between these, I go up to my max, and in between these, I go down to my min. So I go, oh, this is so exciting. I hope it's better on your piece of paper. Oops. I'm bad enough at this on the board, and on here just makes it worse. Okay. Okay, so this is the graph of y equals 3 sine 2 theta minus 1. Okay, so now I'm going, so you notice that I did the first 3 things, and now I'm going to apply the shift. So every point is being moved over pi over 6. So each of these is worth pi over 2, sorry, pi over 4. So a sixth, how does a sixth compare to a quarter? Well, it's a 2/3 of the way. Okay, so this will be moving over to here. I don't need it because it's less than 0. It only told me to graph between 0 and 2 pi. So this will be moving over not a full pi over 4, but just a sixth, so about here. This will be moving here. This will be moving here. Okay, so something that could have made your life a bit easier is if, could have made my life easier, is if I had made my scale a bit bigger. Or if I had gone in increments of 3 instead of increments of 2, because then pi over 6 would be a lot easier to represent. Okay, now this is kind of annoying. So we're going to go from here, up, down, up. Okay, but you can see that it's clearly shifted pi over 6 to the left. And then we'll go up again. Okay, So there you go. And if you want, you can label these points. So you just have to do pi over 4 minus pi over 6 to get the x value. And then the y value is 2. So any of these x values or theta values, you just have to subtract pi over 6 from them to get what they are. Okay? So there you go. There is the graph of our y function. Okay, going back to the note, I'm going to go to the final example here, which is, there's a lot to take in here. So a mass on a spring is pulled toward the floor and released, causing it to bounce. Its height in centimeters above the floor after t seconds is modeled by this formula. So notice that k is not factored out, so we're going to have to factor out k. All right, and it's only from 0 to 3 seconds. So it's saying that it has this perfect bounce for the first 3 seconds. Sketch and predict when the mass will be 18 centimeters above the floor as it travels in an upward direction. Okay, so we have to start by analyzing our function before we sketch it. So to do that, we need to factor out k. So k is just 2 pi. So when we factor out 2 pi, we get t plus 0.75 plus 15. Okay, if you're wondering where I got 0.75 from, that's just 1.5 pi divided by 2 pi. So if you do that, on the pi's cross off, and 1.5 divided by 2 on your calculator is 0.75. Okay, that's where I got that from. So let's analyze this function then. So our a value is 10, which means that the amplitude is 10. Okay, our c value is 15, so therefore the axis is y equals 15. Okay, so using these two pieces of information, we can come up with our maximum height is just, we take our axis 15 and add 10, okay, our amplitude, and that gives us 25. And the min height, we can take our axis, again, 15, and subtract the amplitude, 10, and get 5. So this goes from 5 meters, centimeters above the ground to 25 centimeters above the ground. Okay, our period is 2 pi divided by k, which is also 2 pi. So that means our period is 1. And t here is in terms of seconds, so therefore it's 1 second to complete one bounce. So therefore, if they want us to model this in the first 3 seconds, it's going to show 3 cycles. Okay, there's also a phase shift. 0.75 to the left, as we can see up there, okay? Because it's plus 0.75, so that's to the left. Okay, so I actually graphed this and put like little ticks on my just right on my page, but I won't be able to do that very well here so I'm going to go back to my graph paper and just erase this and graph it on here. And I guess that the line will not erase. Let me see if I can get rid of that. Look at me. Okay, so we want up to 3 seconds here. So I'm going to say this is 1 second, 2 seconds. I'm going to cheat a bit and say that's 3 seconds, okay? So here's half a second, 1.5 seconds, 0.5, 1.5, and 2.5. Okay, this is going to work later because when I shift everything 0.75 to the left, then that's going to be just 3 of these because one of them is 0.25. So this scale works better than the one I did before. So it's just a learning curve you guys have to get used to of how you make your scale. So again, I'm going to apply my axis. So let me put the equation here. 10 sine 2 pi t plus 0.75 plus 15. So again, our axis is 15, so I'm going to go up to 15. So I'm going to go up in terms in 5. So 5, 10, 15, 20, 25, 30. That's perfect because I know my maximum is 25 and my minimum is 5. So I can graph my axis. That's what I always want to start with, okay, is graphing my axis and labeling it with its equation, please. So that's y equals 15. Okay, and I know that this is a sine curve. It has not been, and I'm not going to apply this yet. So I start on the axis, and after one full cycle, I end on the axis, and I'll also be at the axis halfway in between. Okay, in between my first two axis points, I hit my maximum, and in between my second two, I hit my minimum. Okay, and this cycle continues. This exact pattern continues for the next two cycles. So again, I'm going to the ends of the cycles into the middle. Halfway between I go up, and then halfway between I go down. And then halfway between I go up, and halfway between I go down. And this gets me my nice curve. Isn't it just a thing of beauty? I love sinusoidal functions. I actually really do. Okay, so now I just need to apply my phase shift. So I take every point and move to the left 0.75. So 1, 2, so again, I picked a good scale because that's just 3 units. So I'd get a point there. This one, 2, would be here. This one would be 1, 2, there. And then this one would be 1, 2, 3 here. So this part isn't actually part of the graph because I don't go for less than t seconds. Oh, I should be labeling this is t and this is h. Okay, so now is where the real fun comes in. So I go 1, 2, 3. 1, 2, 3. Okay, and I can see what's happening. I can start filling in the pattern without actually having to count everything over once I kind of get going with the pattern here. Okay, so notice it's starting from its lowest position and going up, and then a second later it's back down. So it's completing one cycle, bottom to top, each second. So in 3 seconds, it completes 3 of those cycles. And so the purple one now is your completed final graph of f at x, or in this case, sorry, h at t. Isn't it beautiful? I just love it. Okay, so now the question says, when will the mass be 18 centimeters above the floor in the upward direction? So 18 centimeters is about here, right? So we just want to use the graph to see how many times does this happen. Well, on the way, again, we're using purple. On the way up, it happens here. So that's between 0.25 and 0.5 seconds. And then it hits on the way down, but it only asked us about the way up. Again here, so between 1.25 and 1.5 seconds. And then again here. So those 3 places. Okay, because again, it said in the upward direction. So we're going to find a number that's just above 0.25, just above 1.25, and just above 2.25. Okay, so let's get to work. And actually doing this. So I'll go back to this and we'll actually do the work here. So we need to take our function h at t and solve it for when it equals 18. Okay, and then interpret the responses so we're only taking the ones that we want. All right, so we take our 10 sine bracket 2 pi bracket t plus 0.75 bracket bracket plus 15, and we want to know when that equals 18. So we can move the 15 and the 10 over. So we subtract 15 to get 3, and then we divide by 10. So we get the sine of 2 pi bracket t plus 0.75 equals 0.3. Now, if you remember from last year, we can't do anything with this because it's called an argument. So what we say now is we're going to let u be equal to whatever this is, whatever the argument is. So in this case, it's 2 pi t plus 0.75. Okay? Now, we're looking for t between 0 and 3. So therefore, we're solving for a u between 0 and 6 pi. Okay? Because this is 3 cycles of our question, and this is 3 cycles of a normal sine curve, 2 pi times 3. So now we change this into sine u equals 0.3, and now this is just a regular old trig question. Okay, so we draw our axes. Where would sine be positive? Well, sine is positive in this quadrant, so here's our first u that we need to solve for, and sine is positive in this quadrant, so there's our second u we need to solve for. So beta, they share the same related acute angle. In this case, it's actually just the same as u1, and we'll use it again there. So beta is equal to the inverse sine of 0.3. So you just use your calculator to do that, but you need to make sure it's in radians. So beta is going to be 0.305. Okay, this is the big thing you use to make your decisions. Okay, so remember, we only need to know the value on the way up. So if you compare this back to the picture of the graph, that's only the first one, not the second one. So we actually don't even need to solve for this one because this is on the way down. I mean, if you do solve for it, it's not wrong. Just make sure you don't include it in your final answer. So therefore, our first u value is just equal to beta, so it's 0.305. Okay, so to get that back to a t form, we set that back equal to what we know u is. So 0.305 is just u, so you set that back to 2 pi bracket t plus 0.75, and you just solve for t. So divide by 2 pi and then subtract 0.75. You get t is equal to negative 0.701. Now this is not going to be included. Why? Well, because of the phase shift. Remember, that would have been actually this one here. So that was our original one from the blue one, but it got shifted over. So that's why that one is not actually included. So to find the next one, you just keep adding periods. So in this case, the period is just 1. So just keep adding 1 second to everything. So our T1 then, we just add a second to that. Okay, and that gives us 0.2985, and that fits the picture, okay, that it was above, just above 0.25. So then our T2, we just add 1 second again, so 1.2985, and then our third time, we just add a period again, so 2.2985. Okay, so then you can write a nice little sentence. Okay, so we have those 3 times. They fit with our graph. They match where they should be based on our scale. Okay, if you did use your knowledge of trig to find the size of U2, again, that's not wrong, but you have to know and interpret that that's actually the time that it's at 18 centimeters, but on the way down. And the question just asked for in the upward direction. So just make sure you're reading the questions very carefully. So if I went through that example too quickly, please, please, please come talk to me about it. Make a note. I know it's a lot of information. It is review from grade 11. The only difference, honestly, at this point is that we're working with radians, but I know that it's a lot of algebraic work going into it. So thanks for watching, guys. Study, make sure you're asking me questions, and I hope you learn lots.